I gave you guys these two equations, and I asked you guys the question, are they the same or different? And then what did x represent? Did it represent a side, an angle, or neither? Well, they are the same. They both have sine, but they're different because one has an angle and one has an unknown angle. Then I asked you guys, well, draw a picture. So let's draw a picture. Sine of 30 degrees means I have the opposite over the hypotenuse. Well, if you think about it, sine is the opposite over the hypotenuse. So here, x does not represent an angle, because it's not on my picture. X does not represent a side length. It's not on my picture. If you put in the sine of 30, you get 0.5. Therefore, x represents neither. It is neither a side length nor an angle. It is actually a ratio. The ratio is 0.5, or 1/2. Why is that important? It basically tells me the answer is that there was no values I gave you, but it's actually, this is actually 1 and this is actually equal to 2. So I can give you anything. That light post over there is 10 feet tall. That means from the top of the post to where you're standing from, if it forms a 30-degree angle, then it's going to be 20 feet. Let's look at this other problem over here. X here represents, let's draw a picture. Anytime you have a trig function, right next to it, you will always have an angle. What do you have, class?
Angle.
Well, that angle is inside the triangle. And then you still have the same thing, opposite over the hypotenuse. So here, x actually represents an angle. And what did I just teach you? Well, you can actually solve for that angle using the inverse. So inverse of sine of 0.5 will actually give us x, and when you put in your calculator, you'll actually get 30 degrees. So in some ways it is the same because it is the same triangle, but I wanted to show you that a lot of times in math we're solving for x. I want you to think about what are we actually solving for.